Well, I am finally back, and holy moly was that CV boot problem a problem. It was just such a pain. To reiterate kind of what happened is basically the CV boot was rubbing on the control arm, the upper control arm at ride height, and basically a clamp ended up clipping on the control arm too and twisting the whole boot and destroying one of them. So I went through literally a catalog of, I think there were 900 CV boots in it, like the all standard, 3-bellow type boots. And I went through all 900 of them multiple times. I was taking measurements off them, off the drawings and the diagrams in the catalog. And I literally could not find a standard 3-bellow boot that would work because all the boots step up in diameter on that first bellow. And that's the most critical area for clearance. So I ended up using a gator style metal boot. And honestly, let's just get into it because this was just such an annoyance, this problem, but I'm pretty sure I got it fixed pretty well. So I've been getting right to work on getting these axles apart. It's pretty easy to take them out. All I did was remove this upper control arm bolt. I removed the stay bar bolt and I loosened the bolt down here. And then this was able to just slide back and I pulled the axle right out along with the spring and perch. The axles, apparently, they don't come apart, but they do. They do. So what you have is you have this outer CV part and you have this cup. Basically how this works is the CV joint, which is right here, was basically on this spline here. And this was all, like this. So what you have to do is you have to hammer this piece off of the CV, slide it up, and then you can twist the CV, pull it out, pull out all the balls and everything, and then pull out the clip on the end and pull off the cage and everything. So these do in fact come apart, and I did find a CV boot that is going to work perfectly. I got it from FCP Euro. It's for an E36 BMW. And the part number is 302337. This is a GKN kit. And you can see the boot is quite a bit better shaped for my application. Just kind of comparing them like this, you can see big difference off the bat is this part is actually way closer to down there. So it actually moves it away from the control arm, and these diameters are much smaller, and it's gonna work a lot better than that old boot for the Mark II axles. As you can see, I got this on and it fits great. And I'm gonna go test fit it in the car real quick and I'll show you how much clearance I'm kind of working with. So let's go do that real quick. So I got the suspension jacked up to ride height. Basically I just measure from here to the fender and you can see how much room we got now. Look at all that room. Basically a good amount of room now. You can see I'd say probably 5 to 10 millimeters, probably 5 millimeters here and a lot more on the others. So pretty happy with that. You can see it's not touching there anymore. With the old boot, it would actually just rub at ride height. So let me crank it up a little bit more and try and bottom out the suspension without this board flying out. You can see right about there is where the boot starts touching up here. And if we get our measuring tape and measure that, you can see we got about 12 inches. So if the suspension moves more than 2 inches, we're probably gonna have boot rub. And we should have plenty of room now with the clamp not having an issue hitting the control arm either. Now we just have to worry about this boot, part of the boot right here rubbing. But you can see it still has clearance even with it compressed 2 inches. So I'm gonna keep compressing it, see if I can bottom it out and see if it hits. But I really don't see it hitting. And we're gonna limit the bump stops that I bought anyway to maximum of 2 inches of travel, so we won't have any unforeseen collisions like the last time. Gonna get these axles all thrown back together, get them back in, install the bump stops, and keep moving along. So it's like a week later. Basically, this new boot that I tried did not work. This is the original one I had on there that rubbed really badly. And if we kind of look at them this way, it's kind of hard to see, but you can see the diameters of this and this are much smaller, but this one still has the same diameter at 85 millimeters. But you can see if we align them up, you can see this one is moved that way a little bit. So I thought, oh, well, maybe this one would clear since it's a little bit more towards this way where there's more room, but it's still just like you have like that much clearance between this boot. These two clear pretty well. It's just this one, and you just cannot find a CV boot, you know, that has bellows that steps down. And the big issue is that this diameter that this boot goes on is like 65 millimeters. So the boot outer diameter minimum is going to be like 75, and that makes this bellow stretch out a little bit. And it's just, there's just not enough clearance to use this style boot. No matter which boot you use, no matter which bellowed boot you use, it's never gonna work. There's never gonna be enough clearance. So I had to engineer a completely new solution using a completely different style boot. And again, the disadvantages of this boot are no clearance. When it spins, the centripetal force is actually gonna make the boot's bellows expand. And also, just the rubbing is such an issue. You know, if you have any rubbing on the rubber, it's going to get worn down very fast as it's metal and rubber, as we saw with this one. So 3 disadvantages of this boot, and now I'm going to show you the new solution I have and how it is just way better. So these style boots are never going to work. I searched a catalog of like 300-400 boots. I measured them all using the catalog's diagrams. It's just a boot would never work like this. And really the issue is this cup. This cup needs to be redesigned to either support a smaller diameter boot or something else. So let's check out the new solution I engineered to fix this problem. So here's the new boot I'm going to be using. It is called a gator boot. It's used very frequently on like prop shafts. This is actually off the 3.2 liter inline 6 and 4.4 liter V8 XC90 prop shaft. And you can see the diameter is just so small. The biggest diameter here is 85 millimeters and the diameter here is 57. And these diameters are basically in the same spot. And obviously you're probably gonna be saying, well, how the hell are you gonna bolt this on to, you know, this thing? But I will show you right now that I made this 3D printed adapter plate. And you can see it has little set screws here and also a nice tight sealing surface so that it can lock into this groove right here. You can see this groove right here. And then the O-ring goes in that groove there and seals the CV grease and everything. And then this bolts up to here. And yeah, shout out to my dad for giving me the idea of these set screws. I was just gonna rely on friction to keep it on, but set screws are a good idea. So obviously this is gonna go on, but obviously with the bolt holes aligned and bolts in there. And then if you compare them, we're gonna compare these two edges. It's kind of hard to do since this is 5 millimeters more this way for those set screws to engage. But I guess if we kind of look at it this way and make these level, you can see that where it's rubbing here is actually now a 57 millimeter outer diameter versus 85. So the amount of space savings is crazy. So we're not gonna have any clearance issues with that anymore. This is such a slim boot. And again, the advantages of this boot are if there is any rubbing, it's gonna be metal on metal, so it's not gonna tear the boot. The boot is internal, so it's not going to be expanding when it's rotating really fast at high speeds. And also it is not going to be able to, basically, it's just way smaller diameter and it's not gonna be able to rub on anything and get destroyed. And this boot has a good amount of, flex in it. It can go, I think, 6 to 11 degrees. And at ride height, my axles sit perfectly flat. So that's not gonna be an issue with this having to move because it's literally gonna sit flat like this when the car's on the ground. The axles sit perfectly flat, which is actually perfect. So this is gonna work really well. I'm gonna try and make it and use the 3D printed version at first because this is 100% infill. It is extremely strong. Like I've tried breaking it with my hand. I cannot break it. I think using a 3D printed version would actually be fine for durability. And there's really not a lot of heat back there. Maybe some heat from the brakes, but not enough to make this, hit its glass transition temperature. But if these work for 50 miles at no clearance, I'm gonna order a set out of 6061 aluminum, and maybe we can switch to those eventually if these ever break. But you can also see this pulls out. So these are actually basically gonna be the same exact height too. It's literally perfect. It fixes all the issues and it's gonna fit really well, and it's the same overall height and everything. And I spent hours and hours trying to find a boot that will work, and I saw one of these and I was like, this might just work. The only disadvantage is this inner diameter is 21, so it's got to be stretched over a 26 millimeter shaft, but that's really nothing. Like this one's 23 and that one's stretched no problem. And this is a lot more thinner, stretchy material. So I don't think there's going to be any issues there. And yeah, like I said, you know, this is going to be O-ring to seal CV grease, and those set screws are going to bite into there so that I can't get pulled off. Even though with the 3D printed version, it's a very, very tight fit. But for the metal version, those set screws are going to be nice. And then obviously bolts are going to be holding the actual gator boot to the actual adapter plate. And it's all the same length and everything. It's all the same diameters, except for obviously here it's way lower diameter. So there's going to be a ton of clearance. So let's run to the garage. We'll test fit this on just the CV. And then we can take a look at our clearance, and if our clearance is good, we can throw the axles back together and put some miles on these 3D printed versions. I don't think there's going to be any durability issues. And if those work and we don't have any clearance issues and get good mileage on it, I'm going to send these off to get manufactured in aluminum, and it's actually very inexpensive to do that. So let's get to that garage and try these out. I have a whole ton of room now. You can see whole finger now at ride height. Like that's a lot of room. A little bit tight up here. Might have to radius this adapter plate a little bit, but like so much room now. This is at ride height too. So like this should be no problems. There you can see, get a good amount, get all my fingers basically between there. So that should be pretty good amount of clearance. Let's lower the car a little bit. Let's say 2 inches of suspension travel, basically almost bottoming out. You can see how close the control arm's getting to here. You can see still got decent clearance, can still get my finger through there. It's getting a little tight here though, so I'm probably gonna have to radius this, or maybe not even radius, maybe just I'm blanking on the word right now, but we can put something there to make a little bit more distance. You can see I got to get different brake lines. These are the 2000 V70R brake lines meant for these calibers, and look, they're stretched to hell. That's a recipe for disaster. I'm gonna order these same brake lines from the same company and just ask them, hey, can you make them 2 inches longer? Because that's scary how tight that is. That could just get ripped and lose all my rear brakes. Not good. Got to fix that. These are gonna work. Plenty of room, plenty of clearance. And you can just see, even with the suspension way down, look at all that room right there now. And if there is any contact, well, there really is never going to be contact there because the suspension's going to bottom out before that hits. But if there ever is, it's metal on metal. Who cares? Looking really good. Next, I'm going to make sure it fits on the actual axle, because this ID right here is a bit small, but I think it should have no problem. Just got to stretch over this and then clamp onto there, and should be good to go. Going to test that real quick and print another version of those, hopefully with the edge radius, and should be good to go, I'm thinking. I was able to get the boot over the axle no problem. You can just see how low profile this is compared to this Gigano. It's looking really good, and the axle actually looks pretty cool having that style boot. Not really, I didn't put the CV in, but you can see there's not really a lot of movement, but that's fine because when my car's level, the axle is literally completely straight like this. So maybe at full droop when the car's on the lift, maybe these will, you know, angle a little bit, but I don't think it's going to be enough to cause any issues or crack this. This is looking really good, guys. I think this is going to work, and I'm super excited. I'm going to print a new version of these with a fillet going around here, and I'm also going to I might move this actually back more this way. You can see there's like a decent amount of space there. but probably not, because that's going to give me a good amount of meat for these bolts to go into. I'm pretty happy with this. I got clamps for this side. I don't think I'm going to have any problems with this, and I'm pretty excited to see how this works out. So let's get those final versions printed. We can get them thrown on and hopefully get back to driving the car. Right now I'm just seeing how the boot looks at full droop. You can't get full droop with this style boot. It just doesn't have the angle. But I mean, this is pretty close to full droop. It is, you know, not too far away. So I don't think that's going to be an issue. It's just that the angles are going to stop the suspension from falling all the way down. So whatever, that's the trade-off. If you pop the boot off, you can see there's plenty of room between the adapter plate and the shaft. No issues there. So I think this is going to work really, really well. I think the only issue where I could see this plate breaking, the adapter plate is maybe at full droop when the car is up in the air on a lift. But other than that, it looks really good. Everything is clearing. So now with everything fully installed, I'm going to raise the suspension up to ride height, and we'll see how things look. Good amount of clearance now. This is at ride height. I can get my whole hand between here. Still good clearance up here. No clearance issues with this clamp, it looks like. That looks like it's going to be have plenty of room. You can kind of see our bump stop. We got not much really, but I'm going to run that for now just to get the car driving, and then we can fine tune the bump stop and the dampening, because the bump stop's really easy to get out with the wheel off. You don't have to take any of the suspension apart. So yeah, I'm going to bolt this suspension back up and we can start up the car and go for a quick test drive, and also get the axle nuts all torqued up. Looking good. So I ended up having to make a second revision cup. This cup basically just allows the CV part in here to come more this way, like towards the diff, because before it was actually being limited to like, it was being limited to a crazy amount where like it was traveling, it couldn't travel like the 20 millimeters it needed to on full sag, which would basically pull this out of here. And so I fixed that, and now you can see our axle has a ton of movement at full sag now. So I'm gonna try pushing it forward. You can see, it's kind of hard to do with one hand, but I pushed it forward a little bit. It can go more, and then you can pull it too. It's really hard to show, but the axle can go this, do that now basically. So we're gonna have to print another one of these and redo the other side. The other side, you can see this boot's fully stretched because this CV doesn't have enough room to come out more. Whereas on this side, you can see, look, fully relaxed, fully stretched. So this is gonna fix this issue with the cup, and hopefully allow us to not have issues with this popping out with the suspension at full sag. So yeah, I pretty much fixed this issue with the boot. You can see this is where the OEM little indentation was for this style boot, but this one I moved way in. So basically with this extended all the way out, you can see there's like not a lot of pull on that. And it's always gonna be pulled all the way out on full sag. And when it angles, you can see now the metal is hitting the metal. So there's no more pinching of the, this pinching the rubber between the shaft and this. So that's fixed. And then if we put it all the way in, you can see it is in there, and there maybe is a possibility of that clamp kind of messing up the boot possibly, but the only time the CV is ever going to be all the way in like this is when the car is sitting level. So there's not going to be a lot of rotation of the shaft, so there shouldn't be any issues with that metal clamp hitting on the inside and tearing it. Not too worried about that. Pretty happy with this. I got 2 brand new plates. I got bolts, or new bolts. And I also bought 2 new boots because the other ones just had a little micro tear in them, and I don't want to mess around with that. These are cheap. These are like 10 bucks. So gonna put these together for hopefully the last time, and everything's fixed now. The CV can pull in and out full length. We fixed the issue with the clamps. We have good adapter plates now, and let's put this thing back together and pray we never have to take these axles out again, hopefully ever. So got the axles all finished up. You can see it full droop now. They kind of rest on the clamp, so we're not gonna have any more issues with the rubber tearing. Other than that, took it for a little drive. Axle has plenty of play this way. Tightened up the clamps on these, or the internal C-clips, and these aren't coming out now. They're both stuck in there, you can see. So yeah, I think this is gonna work pretty well. Sprung a leak somewhere over here. It looked like it was coming from on top of the surge tank. I remember Hussein had an issue where his actually bursted because of all the pressure in it. So I wonder if he had to weld it. I think this is what he ended up welding, but I wonder if there's another failure up there. But it just seems to be one thing after another. I don't know what to figure this out. That just started happening, but other than that, pretty happy with the axles, and gonna call it quits here for this video.